Welcome to Uptime Spotlight, shining light on wind energy's brightest innovators. This is the progress powering tomorrow.
We're back with Lene Hellstern, the Director of Engineering at Peak Wind, and we're talking about onshore wind siting, which is a really critical issue that a lot of operators have difficulties with. And I've seen it in the United States, and it's not good. And I'm wondering, from your perspective, what are some of the problems, Lene? Well, first, welcome back to the podcast.
Thank you, and thanks for having me.
Repeat
Pleasant
guest,
experience last time, so
I
I
hope
thought
so.
I'd pop in again.
Well, it's good to have you back.
And
But-
thanks for coming to Copenhagen.
Yeah, well, we love Copenhagen. It's great. I just wish it was a little bit warmer. The
Yeah.
sun is terrific
Yeah,
when you're in
well,
it.
at least I fixed that, right?
Yes,
It's not raining.
it's not raining.
Yeah,
Yes, we quite enjoyed it. But I'm trying to get an understanding of what the underlying issues are with onshore wind siting and why some of the operators have difficulty later on. Let's just start with the siting itself.
Yeah.
Is usually we'll see a wind mast out at site for several months, maybe a year, maybe 2 years, to try to get some wind data.
We would really like that, yeah.
Okay.
But the preferable measurements are LIDARs.
Oh, LIDARs. I
Yeah.
have not seen a lot of LIDARs in use.
No, you need to get some more
Why?
because they reach higher.
Okay.
And you can move them around, right? And the hassle of installing a met mast that's 100 meters tall is
a problem.
quite. It costs a lot more.
Yes.
Right? And the lidars they are better and they measure higher, and you can have one sort of mother lidar, and then you can move the other around, and you can cover your wind resources and site suitability much better on the site. So I would definitely recommend LIDARs.
Okay. The LIDARs use a good bit of power to make them run, correct?
Yes.
So
Yeah.
you need a
You need
decent power source.
Yes, you do. Yes.
Okay.
Yeah.
Is that one of the difficulties why they don't use a LIDAR? Is it just in a lot of remote areas they don't have the power source to run it?
It could be, or it could be the lack of knowledge, right? Traditionally, we have used met masts.
Yes, forever.
So it could be, and then there are also some issues with uncertainties because the LIDAR is, the standards are not up to date, I would say. That's the correct way of saying it. So the standard actually introduces more uncertainty on the LIDAR that's really not necessary due to a calibration with a met mast. So there's some things that needs to improve in that area.
Because a LIDAR should be a lot more accurate than a met
Yes,
mast.
Yeah. But the downside of the LIDAR, so that is not often we see that, is if you don't have enough particles in the air, you have an issue, because then you're simply not going to be able to measure the velocity of the particles because they're not there. And then you have a low availability on your measurements. But most places there's quite a lot of dust, there's pollution, so there are things in the air that we don't see, but the LIDAR see, and then you can make the measurements.
And as the hub heights have gotten taller, it gets a lot more difficult to get a met mast
Yeah.
up that high. So
Yeah.
the LIDARs can measure winds how high up in the air? How many meters?
I think at least 250 meters.
Wow.
And you want to, traditionally you would only measure at hub height, but you want to measure at the rotor surface, right? So you want to measure at tip height, and you want to measure at top tip and lower tip, to see for instance, what's the wind shear across your rotor disc.
Which you cannot really do with a met mast at
You
all.
can't do
You
that.
have no wind shear knowledge from that
You
instrument,
can,
sort of.
Yeah, you can, because you can make, you have a met mast that's at least at hub height, and then
Right.
you have anemometers and wind vanes and I don't know what all the way down. And you can, without that equipment, you can measure on the lower part of the rotor, but not the upper part. So you do get some possibilities to measure wind shear, but not as good as, for instance, LIDARs. Yeah.
So how many LIDARs would you typically need on a 100 turbine site?
Well, that depends.
Okay.
Because you have, if you have complex terrain,
Right.
yeah, you may want a lot, right?
That's what I was wondering. If
Yeah.
the more hills and valleys,
Yeah.
the more LIDARs you will need, or more samples you'll need, or maybe the longer duration you'll need.
Yes, yeah. And you would want to, it's always the best to measure. I think it's ideally 5 years. Nobody does that.
5 years,
Yeah.
nobody.
No. But you should at least have 2, right?
Yes.
And then you should do a proper long-term correlation. So
And
that's
how's that accomplished right now? Let's just say we have a met mast. What I typically see is there's been a met mast out in the middle of the United States where the winds are pretty good.
yeah.
And they have data. They have some
Yeah.
data. So typically I've seen them out there a year, maybe 2 years. And then, but the sites are massive.
Yeah.
They're square miles,
Yeah.
dozens of square miles. So it's big.
Yeah.
I don't know what it is in kilometers, but a lot of square kilometers. So then they are trying to interpolate that data that they have from the met mass. On top of that, I think they're looking a little bit forward in terms of what other wind farms may be surrounding us in the next several years.
Yeah, and that's one of the challenges we have because there's a lot there's a lot of guessing.
Yes.
So if you are planning a wind farm, you want to know what goes on in the area. You want to map out the already existing turbines and what height, what rotor size, because you want to be able to model them in your calculations.
Now, that was really get to my question about how difficult this process is and how you try to address it. In the United States, we turn over wind turbines every 10 years, so there's a repowering happening. And almost always, the rotor size gets substantially bigger, 20 to 30 to 50%
Yeah.
bigger, right? So there's fewer turbines, same location. And the turbines are roughly in the same spots, but they're just bigger rotor diameters. How do you then prepare for that? Do you use the old data, or is the old data even applicable if I'm really dramatically increasing the rotor size? Do I need to be doing more LIDAR measurements before I make that repower, or how do I even cite that right?
You can, if you have some good SCADA data from your turbines, you can do some modeling, and many of the
Okay.
sites actually have a met mast
They do,
as
a lot
a
do.
reference,
Yes, right.
But that will be it will have sectors where there's a lot of weight from the existing.
Okay.
So I would filter your SCADA data from your site and see if can I use this. I'll take a look at the met-mass data and see can I use this. If not, I'll start a met-mass campaign. Now the problem is if you're reusing the spots. Now, well, first of all, that's a little bit difficult reusing because your foundation is dimensioned to an old generation turbine. Let's say take someone 100 meter rotor, right?
Right.
But now you're going up in size, so that means everything gets heavier and bigger.
Right.
So your foundation may not be suitable. The old foundation, normally they're over-dimensioned, so you
Yes.
you can extend life or you could repower on them, but you would want a bigger turbine. So you don't necessarily want to use the old position, right? And then you would want to know what is in the pipe. When can I get when can I start digging, right? When can I start installing? What is in the pipeline at that point from the OEMs? Because sometimes it actually takes 5 years from you start planning until you start digging. And in that time, if you space with today's models, you're going to have too short a distance between the turbines because the new turbines on the market that you would want to buy has increased significantly.
And that's a real problem. Like
Yeah.
this between the sighting time, the met mass, the LIDAR data, getting enough data, and having to make the decision about a turbine relatively early because the production lines are not operating at full capacity right
Yeah.
now. It's hard to get a turbine, so you are 3, 4, 5 years out.
Yeah.
How do you plan for that on an onshore site?
Well, you got to guess a rotor and guess a turbine
Okay.
size, right?
But
So,
do the engineering staffs at a lot of operators have that inside knowledge? Because it seems like smaller operators, I'm not, the Earthfuls of the world have power and they can see inside the factories and they have a really good connection and they develop that connection over a long, many, many years.
yeah.
Where newer operators usually do not have that sort of
Oh.
insight. So where do they go to get help?
Well, they could go to peak wind, right? We could help them a little bit, but you can also if you look at the evolution of the turbines, you can, and I'm hoping we are at a little bit of a pause here, in the growing size, so we can refine the turbine, we can refine our manufacturing facilities, we get better at service and installation, but you can pretty much, guess the rotor. I've done that a lot in this job and my previous job, because if you look at when did what come on the market and from what OEM, right? And then there's other topics you need to look into. For instance, site suitability, right?
Right.
What are the conditions on the site? Are you we categorize in different classes, IEC 1, 2, 3, or turbulence classes A, B, C, and then there's the class I like the least. That is the class S, which is special, and then you never know what it is before you start digging in all the paper. But that's sort of the first things you need to find out. What class are you in? And then there's a small abarabá in that, because you may think you are a class 2 or have a class 2 site, but then it turns out that your air density is unbelievably low. So sometimes you can actually squeeze in a class 3 turbine on a class 2 site and get that much more production.
Do a lot of operators know that?
No.
Oh, I wondered. Okay.
Yeah, well, maybe it's not so much the operators; it's the developers.
Developers,
yeah,
sure.
yeah.
Yeah.
That has to dig a little bit more into the lovely engineering science around turbines, and then we do more site suitability, because you can actually improve the value of your project quite significantly.
That's what I wonder. If you spend a good extra amount of time, maybe spending a little more money to get LIDAR measurements and to do them for a slightly longer period of time, does that have a return on investment?
You get less uncertainty, right? And then I think some of the issues or some of the mistakes that the developers do, they do a production estimate, but that is not the same as a site suitability. Or also some people also think, if I do a wind resource assessment, then I'm covered. No, because that is the input to the site suitability. Now you also need to do the site suitability. So, I would start out doing a wind resource assessment, right? Then I would do a site suitability, and then you do your production calculations.
And how long does that process take, generally?
Oh, there's always a queue. So it could take, it depends on who you use for this, right? But it could take 4 to 8 weeks.
Okay, that's not horrible.
No.
All right, so it is relatively efficient compared to other things that happen in wind.
Yeah. If you have a complex site, it can take longer, because you need to run a lot more calculations due to the complexity of the terrain, right? You can have issues with inflow angles, wind veer, wind shear, all the lovely technical things, yeah.
Well, and because we've developed so many sites to date, all the best wind sites have turbines in them mostly right now, and we're starting to get along the fringes of that good wind area in some cases. Does that change the way you do the analysis and do the approach?
Yes, but some of us have done that for a long time, because it's not good enough to have good wind if you don't have good grid. So for me, a good wind site, I spoke with someone yesterday about the best wind resource in Sweden. But if that area doesn't have a good grid, then I can't harvest the wind, right? And it's the same in the US, right? You have some grid issues.
We have a lot of grid issues.
Yeah, and if you don't, everything is combined. Everything works closely together, right? The technical, the commercial, and the finance. So if that is not well covered or investigated in a project, you don't have a good project.
Is the grid the limiting factor in a lot of onshore sites?
I think the world is becoming more and more electrical, which
it is.
I think it's good. And I don't think that we can point at any government that was super duper on expanding the grid. I know there are issues in Texas There are also issues in Denmark, where I'm from.
There are,
There's
yes.
issues in Europe, so we need massive investments from the government to build out this grid. It's not enough to say we want clean energy and then do nothing, right?
I want to get back into
Yeah.
the meat here, which is turbine selection.
Yeah.
I have my LIDAR data. I have
Mhm.
my Met Tower data. I have, say I have 2 years. I am really the best wind resource knowledge operator, developer that you're going to meet.
Yeah.
Great.
Super.
What do I do next in terms of picking a turbine? How do I even do that? And how does that process look like if I'm talking to OEMs about something that's still 3 years from being developed?
Well, you need to start. You need to have your planning, your permits in order.
Sure.
So depending on what country you are in, some operate where you need to apply for the specific location of the turbines. It's more a box. So it's you say I want to apply for 300 megawatt, 500, please in this area. So then you start looking at your site suitability. What boundaries am I working within? What is my average wind speed in these different heights? How do I get the levelized cost of energy as low as possible? Because some people still sit and look at the net capacity factor, but those days are over, right?
They are, yes.
Yeah. So all alarms should go up if they say good net capacity factor. Yeah. Super. What's your levelized cost of energy then? So then you have a good idea on what kind of turbine class should I look at. Then you start looking at do you want to do self-service? Do you want to have a full service agreement?
Exactly. That's what I'm
Yeah.
really wondering how that works then, because if I know the basics of the wind site, do
Yeah.
I just put a proposal together and slide it to Vestas and slide it to
No,
GE, or is there still more I need to do before I start talking to them?
You need to ask yourself and your organization.
Okay, or
What-
peak.
Yeah, but we would ask you as well, what is your O&M strategy, right? Do you want to do self-perform? Do you want a full service agreement? How risky do you want to make it?
Is that a deciding factor in determining what turbine you want to purchase?
Yeah, because then you may not need the OEM to have a service organization close to your site, right?
So let's say you choose
Yeah.
Vestas because they want to sell you a full service agreement, generally speaking, where a GE typically doesn't care or not so involved in that.
Okay, but then
But
you want to
it-
know, do they have a service organization close
Right,
to?
right.
Or are they going to do they need to build it, right? Is this a new platform? Do they not have any experience with this platform, the people in this area? Because then that's
So it's
always
new.
teething issues, right?
Sure.
Yeah. So
Well, how does that play into your decision making then?
well, if you have let's say 4 OEMs in this area,
Right?
yeah, and then you look at what turbines do they offer? What service agreements can you get? What availability? How does the contracts? You want to benchmark the TSAs and the SMAs,
Yes.
and to see who's the best player here. There's a lot of pieces to the process.
Well, that's exactly what I wanted to get to.
Yeah.
Was I'm trying to understand how deep you're going in this. So you're actually looking to see if they have a service site nearby
Yes.
and what the service people have been exposed to in terms of turbine type.
Yeah.
And also you're going a little bit deeper to see how successful they have been. Maybe you've called the sites
If I have that
around.
information, yes, yeah.
Okay.
Yeah.
So you're making a lot of decisions not based upon necessarily what the OEM is offering as a product, but you're also looking at what does the next 10, 20, maybe even
Yeah.
30 years looks like.
Yeah, and then you want to know what turbines, what pipeline is there, and then you want to do a tender, right?
Right.
Let's say now you're down to 3 because the 4th one that was a no-go. Right, so now you have. That's why I say 4 turbines per site. You need to pick 4 different OEMs. Now you're down to 3, right? And then you issue a tender and you get the proposals in.
Okay.
And then you start negotiating and you do your technical due diligence.
Right.
To sort of dig a little bit deeper and understand the OEMs, right? Also give them a chance to say, hey, this was an issue before, but we fixed this problem and you can see it documented. Or you go, yeah, but you're not there, so I need to account for that. So then you have a dialogue with them, and then you have then the third one is too high, and now you have or can't deliver, or
Doesn't have a production schedule that meets the needs.
Yes, exactly. And now you're down to two, and then may the best one win. Right.
Okay, so you're talking about several months of gyration,
Yes.
meeting with the OEMs, or OEMs coming to you
Yeah.
even to give their pitch. Meanwhile, you're evaluating their technical expertise about their turbine,
Yeah.
and you're questioning how the previous generation of those turbines have performed, looking forward to say,
Yeah.
have you fixed the existing problems, and what does the next generation look like?
Yeah. Oh, well, what did they look into developing a new
Okay.
platform? Right.
So are you thinking about risk in terms of new technology? I'll throw the easy one at you. Two-piece blades.
No, thank you.
Okay, that's a good
Yeah.
response, because I think there was just a lot of unknowns about that.
Yeah.
Yeah, and then now that we have some service history,
Yeah.
we may want to rethink that.
Yeah.
Are there other types of technologies that would lend themselves to requiring further review?
Yeah, but what I'm hoping is that maybe we can pause a little bit on the sizing thing
Right.
and then refine the components a little bit more, and be more innovative.
In the
Instead-
components.
In the components, yeah, and improve the manufacturing quality, installation, service, right? Because sometimes what I see in the industry is it's an old component, but actually it's the people that's the issue, right? Because we're not trained, we don't have the technicians trained well enough. We don't have the people in manufacturing trained well enough, and so we make mistakes.
So then are you looking for OEMs that are doing more reflective activity at the moment, that they're basically pausing new designs
we
and then...
always do that. We
Okay.
always look at, when we do technical due diligence, how is the training in the manufacturing, What kind of programs do the different people need to go through? How do you get to seniority? How do they train them? How do they test them? How many years does it take, right? Because you can't do things in 5 minutes. And
Right.
what's the turnover at a manufacturing plant?
See, but this is why you would choose Peak Wind to help you do that process, because I don't think a lot of developers, and especially in the United States where we see a lot of it, I see a lot of it, developers are about putting turbines in the ground
Yeah.
and then selling that farm to the next owner, right?
Yeah.
So those long-term agreements don't really play into a lot of this, and
No.
from what I've seen. But I think in Europe it's a lot different.
Yeah, no, but we also have, there are different concepts. There is build to sell.
Yes,
Yeah,
right.
That's then they tend not to be so focused on the technology, right?
Right.
And then there's the people that build to keep, right? And
Right.
if you can see that was their intention, and then they ended up having to divest anyway, then you know that they probably did a little bit more work on the technology side.
Which one's more successful? Build to sell or build to keep?
build to keep?
Build to keep has better power production, more revenue,
Less downtime.
less downtime,
Yeah.
because they've done their work up front. And
Many of them, yes, have done it. Yeah.
Ah.
So, but developers can still do build to sell, but then
Sure.
they need someone with the technological glasses
Well,
to come in and help.
Sure, but that's where Peak Wind comes in, because you carry those people on your staff. Your Peak Wind's full of experts,
We would love to, yeah.
so that you can immediately tap the group of experts about the different aspects of this new development,
Yeah.
from training to warranties to technology to just generally how an OEM performs.
Yeah, but
and
it's also the technology, commercial, finance, right?
Bingo, finance, yeah.
They go together, right? It's
Right.
not enough to have a brilliant gearbox that can last 100 years. So if you only need it for 35, right? And you
No,
paid
it's
a
true.
fortune, right?
That's
That's
just
not a
true.
good business case.
Right, right. And there are turbine manufacturers that have that model that do that still.
Yeah.
Yeah. This is fascinating. And I appreciate your time. Every time we talk, I just get more in depth of what is happening and where we can get better as an industry.
Yeah.
And that's what Peak Wind is all about.
Yes, but we are really good already. We just need to
We
get
are good.
better. Yeah,
Yeah, we do need to get better. And I think we do need to take a pause.
yeah.
So how do people get a hold of Peak Wind and to tap your expertise and to bring in the expertise of your team?
Well, we have a webpage where you can contact us through, or LinkedIn. I am on LinkedIn, so feel free to send me a message. And reach out to us, and we would love to help. We also have offices in Boston and Texas. We also have
all around the world.
Yeah, Canada, Seoul,
Yes.
Taipei,
Yes.
Copenhagen. Yeah.
And congratulations, I think you just won, was it in Taiwan, an offshore site that you're going to be operating or managing?
Meow, yeah.
Yes, congratulations on
Thank
that. That's very exciting.
That's my lovely colleagues in asset management, yeah.
Very nice.
Yes.
So, Lene, thank you so much for being back on the podcast. And we have to have you back on again because there's so much to talk about in wind, and it's great to talk to someone who has been around and has seen it and has done it. It's a tremendous learning experience.
It was a pleasure.